Assalamualaikum warahmatullahi wabarakatuh, and a very good and a good day to all. So for today is that we are going to start with chapter 1, which is on introduction to mechatronic system. Okay, so for chapter 1 is the learning outcome will be on LO1, which is on explain basic concept of mechatronic system. And for this, after you have finished this chapter 1, so after completing this lecture, students should be able to explain basic concept of mechatronic system in terms of first one is definition, second one is history, third one is job scope, and fourth is example of application of mechatronic system. So what do you think is mechatronics? So as of now, you are under the bachelor degree of mechatronic engineering, so you should be able up until today in your second year, so you must know what is actually mechatronics. So what is mechatronics? So in technical term is that mechatronics was coined by Mr. Tetsuro Mori in 1969 when he worked for Yashikawa Electric Corporation in Kitakushu in order to propose the new technology to produce a new machine tools by integrating machines and electronics. So actually mechatronics come from the word mecha, which is mechanical. So in Japan, they use the wording of katakana. So katakana means that in Romaji, so the English word they converted into Japanese word, so means that when they use mecha means that mechatronics, and when they have the tronics means that from electronics. So for example, when I was doing my PhD, so we have the I was under the department of mechanomicro, so means that mechanical plus micro is micro, very small micrometer, so very in the field of mechanical in precision. So that's why it's actually another word for mechanomicro is in precision engineering. So another definition of mechatronics is that you can see from Bolton Mechatronics. This is the official reference book that you're going to refer to. So mechatronics means the integration of microprocessor control system, electrical system, and mechanical system. And this one is I take it from a Journal of Mechatronics. So it means the synergy combination of precision mechanical engineering, electronic control, and system thinking in the design of products and manufacturing process. Okay, another definition of mechatronics is by Alciato, and his stand is that the interdisciplinary field of engineering dealing with the design of products whose function relies on the synergetic integration of mechanical and electronics component coordinated by a control architecture. So meaning is that it's actually the combination of mechanical and electronics, and it's being controlled and having a control architecture. So all of these three components are integrated between each other. And this one is from ME magazine. So the synergetic use of precision engineering, control theory, computer science, and sensor and actuator technology to design improved products and processes. So you can see that there are lots of definition of mechatronics. So you can try to search for what are the definition of mechatronics and what are your own definition of mechatronics, since you're in taking mechatronics engineering. So hopefully by the end of this chapter you understand more on what is mechatronic engineering. So let's look at the subset of mechatronics. So you can see that here, that in the middle here, the center is the mechatronics, and it is actually the subset of four main components, which is control systems, computers, electronic system, and mechanical system. So if you see here is that when you cross the computers, the computer component with the control system, then you have the digital control system. And when you cross between computer and mechanical system is that you have the mechanical CAD and mechanical systems. And when you cross between mechanical system with electronic system, then you have the electromechanics. And lastly is that when you cross between control system and also the electronic system is that you have the control electronics. So the outer layer of this circle is that you see that here are the application or the field of mechatronics. So it's actually quite diverse. So you have the automotive, you have aerospace, you have medical, you have xerography, you have defense system, you have consumer products, you have manufacturing, and you have the material processing. So this is all the options that you have available once you graduated from UTEM. So like what I have give you the task in week 1. So what are the job scope of mechatronics engineering? So you come up with the production engineer, you come up with the equipment engineer, you come up with the process engineer and control engineer and so on. So that's good. So at least you know by now that you have lots of options later on when you go for job hunting. So this is what I explained just now. So combination of mechanical, electrical and computer engineering. So it emphasizes on the integrated product design. So all of these 4 products are actually integrated between each other to actually come up with the mechatronics. Okay, optimal combination of appropriate technologies. Right. So let's look at the detail of mechatronic system. So we look at this information on the information system. So you can see here that we have the first part, which is on the information system, which is we have the modeling and simulation, we have automatic control, we have artificial intelligence. So all of this is under information system, and you can see that actually automatic control and artificial intelligence is under control subcategory. Okay, so once you integrate this with the electromechanical, so electromechanical is the combination of mechanical system and electrical system. So when you have all of this is that you have a mechanical system, then you can actually read the movement of a mechanical system by adding sensor. Therefore, you need to integrate it with some electrical system here. And electrical system is actually, you can actually actuate the mechanical system by combining with some actuators. So later on in chapter 2 and chapter 3, you are going to learn about what is sensors and what are types of actuators that we have under what we have under mechatronics. And from this electrical system is that when you want to integrate it to computer system, so you need to actually read the signal from the sensors. Correct. So you need to have the real-time interfacing. So to do that is that you need to have the signal processing, or we call it as the digital to analog converter, D to A, and you have the A to D converter. So digital to analog means that you want to read the digital data, okay, and convert it to analog, which can be read by the sensor and actuator. And vice versa is that when you have electrical system is that you have analog system. Okay, so you want to actually convert it to digital system so that the computer can read the data. So these are the 4 key elements of mechatronics as I mentioned in the previous slide. So we have the control system, computer system, mechanical system and electrical system. And you can go into detail, you can try to find this book online, Mechatronic System Design. So look through this component. And of course, in this chapter also, I'm going to explain it in detail. Okay, so if you see here, under control system is that what you're going to learn for the 4 years you are in UTEM is that you're going to learn on the, in second year and above is that subject introduction to control. Then you are going to learn about control system engineering, and next you're going to learn in digital control system, which is this is an elective that you can have the option to take it later on. And then for the mechanical system subject is that you have the thermodynamics, fluid mechanics and dynamic and mechanism. Okay, and for the computer system is that you have the subject computer programming, AutoCAD and MATLAB. And lastly, but not least, is that you have the electrical system subject, which is on principle of electronics, digital electronics, circuit analysis, and principle of instrumentation. So what is a system. So definition of the system is that a system can be thought as a box which has an input and output. So assume that you do not know what is in a system. So let's say that we have one system which is a temperature measurement system, and you have the input to the system is that you have. So for this temperature measurement system, normally what do you use? What sensor do you use? So let's say that we are going to use a block diagram here, which is a thermometer. So the input to the thermometer is the temperature here, and the output will be the number on the scale. So it means that when you have a thermometer is that you can actually measure the temperature, and by looking at the scaling at the thermometer is that you can read what is the temperature. Okay, and the second example is on central heating system. So you have a central heating system block diagram here. So you have a block here. So the arrow going inside the block is the input, and the arrow going outside of the block is the output. So in this case is that example is the aircon system, central heating system, or this is for example in a four-season countries. So we have a heating system. So let's say that you are required to set the heating system to 28 degree, okay, which is for winter, okay, example. So you set it as a reference 28 degree, and the output is the temperature at set value. So it means that it should follow the reference that you set. So this is an example of a system. So system can be defined as two types of system, which is an open loop system and a closed loop system. So later I will explain what are the difference between these two systems. So there are three types of mechatronic system. So first, the three main types are measurement system. So what are measurement system? Second one is actuation system. What actuate the system? So what type of motor do you use? What type of, is it electrical actuator, or is it mechanical actuator, or is it hydraulic actuator or pneumatic actuator? So these are the actuator that you need to define in your system. And the third one is a control system. So normally if you have a complete system, you need to have a controller inside. Okay, so these are the three main mechatronic system that you need to remember, because this one will be will be actually implemented towards the full 4 years you are here. Is that even during your IDP project, integrated design project, or even in your final year project. So normally I will ask my final year project students, so what are the main component in mechatronic system? So they should be able to explain that there are three types of system inside. You have the measurement system, you have the actuation system, and you have the control system. Okay, so let's look at what are the measurement systems. So measurement system, it comprises of these three main components. So I'm going to explain it from the left side to the right side. So for a measurement system, as it's defined here, is to measure a system. So for example, we have the temperature sensor, temperature block diagram just now, temperature system. So you want to measure what is the temperature, so which is the quantity to be measured, so the temperature to be measured. So in here is that you have the sensor and transducer. So what type of sensor you're going to use? For the case of if you are using a thermometer, can you actually get the data? Can you actually collect the data from a thermometer? No, right? So means that instead of a thermometer, you are going to actually implement a temperature sensor here. Okay, temperature sensor that can actually give you a data, a reading in digital, and you are going to collect the data, which is you can actually represent it into a data presentation system. Okay, so sensor here, the first component in a measurement system is the sensor, and from the sensor is that you have the signal conditioning. So the reading from a sensor normally is very small, in millivoltage, very small. So you need to emphasize the data to reading that the computer or your computer can read, so you need to amplify it. So normally under the signal conditioning is that you have amplifier here, so amplify the reading of the voltage or current that you collect from the sensor output. Okay, so amplifier is the second one, which is signal conditioning. And lastly, after you amplify the data, is that you're going to represent the data in a scaling or in a oscilloscope. So this is where you have the data presentation system. You can have in terms of a display there, or in terms of a 7 display. So means that you can actually plot it in the oscilloscope. So this is where you have the value of the quantity. So whatever quantity that you are measuring here can be actually displayed at the end of the measurement system. Okay, so this one is measurement system. So this one, the details on measurement system, I'm going to cover in chapter 2. So which is a device which convert physical phenomena into electrical system, which is voltage. So this is where you have the physical phenomena, which is temperature just now. We are going to convert it into electrical system, which is voltage or current. Okay, and for the signal conditioning is that you are going to learn it in chapter 3. So to use process and output signal from a sensor to make it suitable for the next stage of operation. So in this case is that you want to display it or you want to use it next in the feedback controller. So you need to have that data, you need to collect that data, because in a control system you need to compare the output of the system with the reference in order for you to control it. So next is that we are going to look at what are the actuation systems. So actuation system is, if you see here, the input is the control quantity. So let's say that I take an example of your car, your vehicle. So most of you are driving your car or driving your motorbike. So normally when you drive your car, do you set who is actually in control of the speed? It's human, it's you yourself. So it means that you're going to press on the pedal, and that pedal is controlled by human. So lots of vehicle right now or automobile that is actually have integrated this, we call it as adaptive control, means that you can actually set the speed that you want, so the vehicle can actually follow the reference speed that you set. Okay, example, in most of the car you have the reference setting. So let's say that I want to set it at 90 kilometer per hour. Okay, so and for this is that when you set it 90 kilometer per hour, means that it's going to convert it to the signal that can be read by actuator. So in the case of the actuator is that you have your vehicle itself, so it's going to give more fuel to the car so that it can either speed up or braking. So and then from here is that you have the output. So this output is actually the vehicle's speed. So if you want to make sure that the vehicle is actually at par with the control quantity, so you need to have a feedback loop here. So you need to feedback this output to the reference. So types of actuator, you are going to learn it in chapter 6, 7 and 8. So chapter 6 will be on the electrical actuator, chapter 7 will be on the mechanical, and chapter 8 will be on the hydraulic and pneumatic. So actuator is actually a type of motor that is responsible for moving or controlling a mechanical mechanism or system. It is operated by a source of energy and convert that energy into motion. So example, okay, it says here that convert the energy into motion. So what source is going to convert into motion? For example, electrical actuator. For all of actuator, there are two types of actuator. It can be linear actuator or rotary actuator. So electrical actuator is something that you see in most of your vehicle. You have the motor, okay, rotary actuator. So the input source is actually voltage or current. Electrical actuator can consists of the electrostatic actuator. So therefore the input is the voltage value, and second one is the hydraulic actuator. So the source is hydraulic fluid, so the input to the system is hydraulic fluid. And third one is the pneumatic actuator, so the source is pressure, which is compressed pressure. And fourth one is the mechanical actuator, is the input is voltage or current source. So how are you going to convert these actuators from the source into a moment is up to how you decide the category, with either you want to convert it from linear to linear, or linear to rotary, or vice versa, rotary to linear. So it's up to you. You need to decide which type of actuator you plan to use.